This is the final and fourth video segment that I'm doing on this sequence of tutorials, and they deal with extruded or swept break elements. Okay, the problem that I'm doing here is very similar to the earlier two video tutorials, except that there is no geometry associated with this object that we're going to do analysis of. For example, in the previous ones, I had perhaps a volume created, and then I created a shell at an extracted surface, and then I swept it. There was a volume there, but here there is no volume. Basically, I have a mesh. You can think about it as if this mesh was imported from another package, and there's no geometry, there's no history associated with it, and you want to do some kind of analysis with it. Here's the problem that you've got. Once again, a 40 millimeter by 40 millimeter cross section like that, okay, and it is extruded along a direction. Think about it as the diagram below it, figure immediately below it, and this line goes between a point here and another coordinate, another point with another coordinate values. So it's at an angle about 45 degrees from the normal to that plane. If you look at the history shown in the tree, there is no pad, there is no pocket, there is no rib, etc. It's all it is a surface and 2 points and a line connecting the 2 points, and I have to create my model based on this. Okay, so let me go ahead and create the model in the vertical plane, in the XZ plane. I will sketch a square centered at 0, 0, 0, 40 millimeters, 40 millimeters. So this is 40, 40, and then the other one is also 40, 40. Okay, we need to create a surface on that. So I'm going to go to the generative shape design and get the fill. Here's the fill. See that? Fill. And this is selected. It puts a surface on that. Then I want to create two points, and those 2 points are the one that you see here, 0, 0, 0, and another one with coordinates 80 and minus 80. So we can do that right here. So here is point, coordinate 0, 0, 0, and another one, coordinate x is 80 millimeter, and y is minus 80 millimeter. Okay, there we are. This is the point. And now create a line. We need a line because this is going to be the axis of extrusion, basically, of the elements later on. And the length of this line, let me see what I want here. The length of this line, I want it to be 113 millimeters. Okay. Actually, no, we can leave it like that. There's no problem. We can leave it like this. Yeah, we can leave it like that. Okay. So the next step is to mesh that surface that we created using the nice surface mesher, which gives you a quad elements only. You can use the regular shell mesh, but I will be using the better looking mesh. So let's go ahead here. We say fine, this is fine. Now we're gonna, let's save this thing. File, save management, save as. Let's see now. I created a folder here, extruded right there, and say OK. Now while we're at it, we apply material on this too. So let's make it out of aluminum, metal, aluminum on this part. Okay, no pad, remember, no pad, no pocket, no ribs, no volume. This is what it is. Okay. This basically defines our, will define our mesh. So now we're going to go to advanced machine tools. and we say okay. We're going to put a nice mesh on this. So there is your surface mesher. There is your surface mesher right there, right there. You click on it. You select the face meaning that's that surface that you created. And the size of these, I suggested that we take 5mm all quad mesh. Okay, so all quad is this is checked. 5mm is already there, and this is it. So we say okay, and then you have to actually measure. This is just specify the mesh size, and there is the see that this thing which says mesh to the part. There we are, and we say okay, and we exit. Okay, there is the mesh that's created. Okay, shell mesh that's created. Now we want to go and extrude this mesh. So let's go back here. If you look at the icons and toolbars, the one that we just used was the surface mesher right here. If you look at this third set of icons, this one is the regular tetrahedral mesh that we are not going to be using. This is a sweep. We don't have a volume, so that's no good. So there is another set of icons here, which the title of it is Mesh Transformation. And I did several video segments on this about 6 months ago. If you want, you can go and check it out. And the one that we want is actually right in the middle, which says Extrude Mesher with Translation. Extrude Mesher with Translation. So you click on this. It says, okay, well, first of all, what is the shell mesh that you want to extrude? Well, it's the stuff that you just created right here. You can select it from there, or you can select it from the tree, right there. See that? Either way. So I'll select it from here. It says, what is the axis? This is why I created that line. So there's the axis. The start is 0, and you extrude for a length of 113 millimeter, which I figured out it's going to be basically square root of 80 squared plus 80 squared. Where is this? Right there, 113 millimeter, 16 layers. Now, where do we do the layers? So let's go here and see on the number of layers 16 right here. You can change it to anything you want, but that's what I'm going to. And then you say apply. Don't close it. Say apply. There we are. Notice that a mesh has been created. A break mesh has been created, but there was no geometry associated with it except for that surface and the direction of the line. Okay, now from this point on, you're going to have to deactivate. You're going to have to deactivate this surface mesher. It has served its purpose. We deactivate it, and in order to deactivate that, you have to be in this workbench. In other words, the advanced meshing tools, and you put the cursor on it. You put the cursor on it. Right click and deactivate. Okay, that's what this transparency says, or this slide says. Deactivate the surface mesh while you're in the advanced meshing tools. Use the right click, and you don't need the mesh anymore. Okay, now what I like to do is I want to create a sketch. A sketch. Now, look at this thing from the top, by the way. Look at how it is. There we are. So I want to create a plane here. I want to create a plane here, as you'll see later, what its purpose is. And this thing is at 135 degrees with respect to the, the original orientation. So the first thing I'm going to do, I'm going to create a plane. I'm going to take the X. Let me see now. Just 1 second. I'm going to create a plane which is X, which is rotation of X at plane by 135 degrees. So in order to do that, obviously you can't be here. I don't see any place that I can create plane. First of all, let's save this thing. File, save management. Here's the analysis. Save as extruded mesh. Very good. Okay. I have two choices. I can actually go ahead and do it. Go to my part right there. Go to my part. Okay. and create that plane that I was talking about. So there is a plane, and the way I want to do that is angle a normal to the plane, angle a normal to the plane. Rotation axis is the z-axis, and the reference is that xz plane. You can take it from the tree, and the angle is going to be 135. 135. Notice that it did create a plane here. It did create a plane at 135 degrees to the xz plane. Okay, now I want to offset that plane so that it ends up on the surface of, there's no surface there, on the side of the extruded mesh. So if you look at it, I'm suggesting that create a plane at 135 degrees from the vertical plane and then create an offset from it 15 millimeter away from it. Okay, so let's see. Where is another plane? Right there. And it's going to be offset. We're going to use offset technique, offset from the one that we created. If the direction is wrong, it's on the other side, just flip it, reverse the direction, and put 15 millimeters. 15 millimeters. Okay, so if you go back to your advanced meshing tools, for example, I double click on that right there, you can see that I created a plane which is not quite on this side, because this side, because of the dimensions that I had, if I had offset it for wait a minute. Yeah, if I had offset it by this, it's a little bit different. It's not exactly on the side, but that's okay. I offset it by 15 millimeters. Okay, good. Save everything. All right, so from this point on, now that the mesh has been created, we need to go to, oh yeah, one thing I forgot on that plane that I created, I want to sketch these shapes. Okay, so that's one thing I forgot. That's no problem. We're going to go back there. We're going to go back to part. On this plane that I created, there is a plane. I will sketch. Okay, so let me reorient it like that. Okay, good. So I'm going to sketch a circle. I may have to reposition these so that they end up in the right spot, or almost the right spot, and a rectangle like this, and a, let's say, squarish like object, or shape like that. Exit. Okay, and that's what this thing is. Okay, now we're going to fill them. While we're here, we're going to fill. If you select that sketch, you'll do all of them, and if you say OK, it'll tell you that, wait a minute, these surfaces that you'd filled, they don't talk to each other, so keep all of them. You can do it with you can keep different one of them depending on what radio button you check, but keep all of them. Now we're going to make sure, if you go back to your mesh right there, I want to make sure that when I look at the side, these are all in more or less on that face. Okay, I don't want this circle to be off that face, etc. This is why I said you may have to go back to it, and that's what this thing means. Fill the sketch and keep all sub elements, and then you're going to go, if necessary, adjust the sketch so that they fit as you see here. Okay, good. Now, the next thing that you want to do is to go to we're done in the advanced meshing tool, and we go to generative structural analysis and apply 3D properties. So that's one thing that never happened. It didn't happen because it was not generated automatic. This was manually in advanced meshing tools. Okay, so we're done here. We're going to go to generative structural analysis. Okay, if you want to see your mesh, you put the cursor there, right click mesh visualization. You can see that. Okay, and then there is no property here, so you click on the property. Let me see now. Here's the 3D property right there. You click on it. You select the mesh that you just created. Remember, you created an extruded mesh right there. This is the only thing that you can pick here. You selected this mesh. It puts aluminum on it, and we say okay. All right. Now, so if you go to the next slide, what we need to do, we have to create 3 groups, actually 4 groups, because the back face that I forgot to extract for you, I need to go and extract it. I forgot to do this. See that? No, actually we did extract it, yeah, because we put a surface on it and meshed it with shell element and extruded it. So it is already there. Okay, no problem. So what we do, we need to go and create 4 groups by surface group by neighborhood. One for this, which is going to be the clamp section on the cross section. One for the circle, the clamp section on the side. One for this, which is going to be a force applied to it, and one for the square, which is going to be a pressure applied to it. And the way to do these things, you have to put the cursor. You have to put the cursor there. You cannot go ahead and do it from here, because if you do it from here, where is that? If you do that surface group by neighborhood, see, there is no room here. It's going to ask for a support, and you cannot pick that extruded mesh. Okay, you can, and there's no geometry to pick here. You cancel that. You put the cursor on this branch, right click, down at the bottom it says create a group, and you go and select surface group by neighborhood. You click on it. First of all, let's give it a name here. Let's give it a name. We'll call this thing X section clamp, cross section clamp. Okay, clamp. Called X section clamp, and make sure you use right now. I'm going to tell you what you should be using for this problem, but then at the end of the tutorial I'll show you what happens if I put a big number here or a small number. Right now 6 is going to do it. Okay, for the support I have to select that. Remember, I extracted the 4 face, extracted 4 well, I had a fill here. This was the cross-section fill right there. This first fill, okay? And we say, okay. Let's do another one. Put the cursor here. Right-click. It may be a good idea if I actually show my part there too. There we are. Okay, that's easier. Okay, so you put the cursor there. Another one. Create group, surface group by neighborhood. Let's call this thing circle clamp. Okay. Again, 6 millimeter, and for the support you select that. Put the cursor there. Put the cursor there on that circle, and you select it. 6 millimeter. Okay. Another one. Create a group, surface group by neighborhood, and I'm going to call this thing rectangular load, rectangle force, because I'm going to put a distributed force on that. And for the support, I'm going to select the rectangle right there, same tolerance. And the last one, you can see that it's more involved than if you had the geometry. If you had the geometry, you would create a feature, you would sew it, and then you proceed. That's it. I can't do those anymore. And surface group by neighborhood, let's call it a square pressure. Square pressure. And you select that thing on the side, that square that you created here on the side. And we say, okay. Because now you can put restraints on these, you can put loads on it. There was no way to do it before, because Catia is a feature-based, package, and its FEA module also relies on that. When it's an orphan mesh like that, there is no geometry. This is where you use these surface groups by neighborhood. You have no other choice. Okay, good. So let's go ahead and apply a restraint. Where's the clamp? There is a clamp. You select the X section clamp. Say OK. Do another one for the circle clamp. Notice that it did put it there, right there. And if you turn it around, you can see that it also put it on the other one. Then we apply a force, distributed force, on the rectangle force. I already put the 500 Newton. I'm trying to use the same numbers that we did in the other tutorials. So these are not real values, so we're just doing it on the fly. And it puts the force on that patch. Okay, and finally the pressure on the square pressure, and it's you know what? Right now I'm gonna put I'm gonna put 500 kilopascal. 500 kilopascal. That's what it was in the other tutorials. Okay, good. The only thing is that the pressure is not shown here. It's not shown. All right, save everything. And I'm assuming that we didn't forget anything. We didn't, yeah. So we're going to run it. I'll come back and show you what happens if we change the tolerance. Okay, good. By the way, in the slides, this is the stage that we are at. We did these. We applied the restraint, and now run and post process. Okay, so we just ran it. Let's go ahead and plot the 1 meter stress, for example. There, change the rendering to material shading, and if you look at the view from the top, you can animate it. Remember, this is clamped, the side face is clamped. You put a load here, and you put the pressure on that square patch. And if you want to see your elements also, so you go to the rendering at the very bottom, customize, and you see the elements. Now, a couple of things I want to show you. First of all, let me deactivate this. Deactivate that. Okay. And I don't need this part, so I'm going to hide it. Okay. So if you go and put your cursor, actually, you know what? Let's plot the mesh. Activate the mesh. There we are. And I'm going to change it to wireframe. So there is a mesh. Okay. If you put the cursor on loads, there's two loads on the distributed. This is a distributed force. Put the cursor there. Right click and say distributed force visualization on mesh. You click on it. See that force that I put on the patch. What happens is that Catia goes based on that tolerance, goes and finds the nodes that fit within that tolerance, which is within that distance of the surface, and creates a statically equivalent concentrated forces at the nodes and places those at the nodes. Because what I gave you is the resultant on that patch. So based on the tolerance, the nodes that come into the picture change. They can be more, they can be less. For example, I'll show you the pressure, and then we go and change the tolerance. If you go here to the pressure, put the cursor on it, right click and show me the pressure. It's right there. You see this? So it finds the surface It finds the surface of the elements which are within that tolerance, and obviously that tolerance is too big, because you see all kind of faces of those elements. So let me go to that. Square pressure. For tolerance, I'm going to make it, I don't know, maybe 1. The other one I'm going to keep it because it looks like the force was okay, but this is not. Now you have to run it. You cannot show it. You have to run it and then show it. Okay, let's look at the pressure again. Pressure, right click, mesh, or pressure visualization on mesh. You see, this is better because the pressure is supposed to be only on these faces of the element. See these these arrows? Before it was everywhere. Even the internal faces were pressurized. Okay, so that tolerance is important. Now the other thing is that, okay, so if we go and say for the force, look at the force, for example. If you go to the force, rectangular force right there, double click. Let's increase the tolerance from 6 to, I don't know, maybe 12. It's going to trap a lot more nodes, and it's going to place forces on them, static equivalent forces on them. Okay, so run it. Obviously, this is nonsense. Okay, let's look at the distributed force visualization. Oh, look, these are all even inside. This is all wrong. Now, I don't even know whether the 6 millimeter, I didn't quite check it in the third dimension. This is all wrong because it's trapping all these other nodes. So let's go ahead and check that. The one that we put 6, that may have been too large also. We didn't check it. 6, okay, run. We may have to reduce that. If there are any loads placed internal to the mesh in the part, obviously that has to be fixed. Let's see now. Yeah, see, it did actually put it on the second layer. That was too much. So we have to, although it looked reasonable, but it was wrong. So rectangle, let's make this thing, I don't know, 1 millimeter, 2 millimeter. I'll put 1 millimeter, run it. I told you that tolerance is important. It requires some thinking. It requires trial and error and checking. Make sure that it's not nonsense. So right click, distributed pressure, and where is it? Right. So make this thing 1 millimeter. And make this thing, well, let's try one. This is 1 millimeter, and this one is also 1 millimeter. Let's try to run it and see what happens. Yeah, see that? It won't run. Okay, so you get the picture. The steps were like this. See, it doesn't run because there are no nodes that are captured within those tolerances. So if you go back here, the steps are outlined. Create your orphan mesh, okay, by taking shell and extrude it. Then deactivate the surface mesh. Create your neighborhoods. Create your features that you want to fill, and then where is this? Yeah, create your surface groups by neighborhoods. They're created. Those tolerances are important. As I said, either you have to think or you have to do a lot of trial and error, and then put the loads and restraints on these neighborhood surface groups by neighborhoods. Okay, good luck. Well, it's not as easy, but at least you know how to do problems if you ever have to import from somewhere else a mesh.